So in 2.4, we're talking about combinations of functions. And when we talk about combinations of functions, there are two main ways we can kind of look at this. And the first one is by what we would call an arithmetic combination. And you can kind of see in the word, it looks like arithmetic. That's because we're going to follow our four basic arithmetic operations, right? Addition, subtraction, multiplication, and division. So the key with these is that the operation in parentheses is the operation we'll use between the two functions. We use between functions. All right, so that means that f plus g of x would be the same as saying f of x plus g of x. F minus g of x is the same as f of x minus g of x, and so on, right? We'd have multiplication, and we'd have division. And of course, the caveat on division is that g of x cannot be 0, as we already know, right? This is nothing new. IB does not usually use the notation on the left-hand side, but it is standard outside of our textbook, so I want to make sure you're aware of it. So just for an example, if we have f of x and g of x defined, and maybe I can color code these. So if I have f of x and g of x defined, I want to find f plus g of x, f divided by g of x, and the domain of f divided by g of x. So let's look at part A. Right, if I've got f plus g of x, well, the first thing that tells us is to use our notation above, right? This is the same as f of x plus g of x. So I'm just going to go ahead and substitute where appropriate. I'm just going to leave a space so I don't have to keep changing colors all the time. 2x squared plus 5 plus x minus 1. I'm going to combine 2x squared plus x plus 4, and I'm done. There's my new function, right? We've taken two functions, put them together, and gotten a new function. So for b, we're going to do the same thing, f divided by g of x, rather. And again, just using my property from above, this is going to be f of x divided by g of x. So plug in where appropriate, f over g of x would be just 2x squared plus 5 divided by x minus 1. Done. And of course, this comes with the catch that x can't be 1. It's going to kind of our spoiler alert for the domain, right? We know that the domain then of f of g of x is going to be all of the x such that x cannot be 1. And this is a little bit curious, right? Because, I mean, the domain of f and g are both all real numbers, right? So we know that the domain of f and domain of g are both all real numbers. So it's a little bit interesting how this turns into both the set of all real numbers to this kind of exclusion here. There is an investigation in the book. I don't know if we're going to get to it. We didn't find it particularly useful last year, so we'll kind of see. If it might be one of those things that we just save for an extra day that we have. So, but this is all it is. Just follow the operation that's inside the parentheses between the functions. When we talk about composition, this is where things get a little more complicated, just because of some of the notation. So if f and g are functions, then we notate what we would call the composition of f with g, so the composition, with this f of g of x, also notated this way. Right, so this reads as f of g. This is not unusual notation, it's just notation we're using in a different way, right? We're used to f of x. We've seen f of 2 or g of 2. Well, now to say f of g of x is just going to tell us instead of evaluating a function with, say, a single variable or a number, we're evaluating a function with another function, and that's all this is. So the domain of f of g is all of the real numbers as long as x is in the domain of g and g of x is the domain of f. And your head might be spinning after you hear that, but it's not as complicated as it might sound. So let's see what this looks like. If I have my function f of g of x, and I have a value x, right? So I've got my value x, it's right here. Well, the first place that gets evaluated is into g, right? I'm putting x into g first. I'm kind of working my way out. So I'm going to apply some function g to x, and that's going to give me the point g of x. All right, x is in the domain of g. That's that first piece here. And we kind of know that this is the range of g. Well, more importantly, if I'm about to take g of x, right, g of x just gave me a number, right? G of x just resulted in a value that I'm going to take and evaluate into f. That's going to become my new input. So I take that value g of x and it gets applied f to it, whatever f is, and that's what gives me f of g of x. Well, if that's the case, then it's less important to call this the range of g and maybe more important to call this the domain of f. So there's our second piece, that g of x has to be in the domain of f. And of course, I guess this is the range of not just, well, I guess it's the range of f, but it's also the range of f of g, which is a subset of the range of f. So we have these two steps at a time, right? I could also take this in one big chunk and say I can go right from x, apply the function f of g, and it gets me right to my final destination. The go-to example I use for this is if we think about Instagram. Hopefully this example stays relevant in years to come. But if I think about Instagram and I post a photo, I can post a photo directly to Instagram. And there's also this button usually that allows me to post to Facebook as well. Well, I have a couple different options, right? I could post it directly to Instagram. Right? I could post directly to Instagram. I take my photo, I put it directly onto Instagram, I save it, and then post it directly to Facebook. Or I check this little box, switch the little switch that lets me just take the photo and put it on Instagram and Facebook at the same time, and that's kind of the best thing I've come up with to maybe wrap your head around what composition of functions is. So let's look at an example. If f of x, I'm going to color code again. If f of x is 2x minus 1, and g of x is x squared, I want to find f of g of x, the domain of f of g, and f of g of 1. So let's kind of get to work here. F of g of x. The first thing I always like to do is to rewrite it right away using this notation instead. I just find it much more helpful. Well, f of g of x is the same as f of x squared because g of x is just directly equal to x squared. Now remember, just like f of 1 tells me I'm going to evaluate the function for 1, I'm going to evaluate this function now using x squared. So my function becomes 2 times x squared minus 1. Whoops, wrong color. And there's my new function. There's my f of g of x. Done. Well, the domain of f of g, I like to just do this based on f of g directly. The domain of f of g is just all real numbers, right? I still have a polynomial function. So polynomial function, the domain is always all real numbers because nothing is stopping me from plugging in whatever x value I want. And the last thing would be f of g of 1. Now I have two ways I can do this. Method 1 would be to find g of 1 and then f of g of 1. So g of 1 is just 1, it's just 1 squared. All right, and because it's f of g of x, it's the same as saying, well, g of x is 1. So f of 1. F of 1 is also 1. 2 times 1 is 2, minus 1 is 1. Method 2 is to evaluate into f of g directly. That's to say 2 times 1 squared minus 1 would be still 2 minus 1, which is 1. All right, it doesn't matter which way I go about it because I'm going to get the same final answer. So I would say use whichever method works best for you.